One of gluconeogenesis, and it's from pyruvate to phosphoenolpyruvate. And you go from pyruvate to oxaloacetate by pyruvate carboxylase. And what that does, it adds a CO2 to pyruvate. Okay, and now you're still in the mitochondria, but you need to get into the cytosol of the cell. So in order to do this, you must go through the malate shuttle. So you take oxaloacetate and it is reduced to malate. And at the same time, reduced to malate, and at the same time, NADH is reduced to NAD+.
Oxidized.
Oxidized, sorry, yes. Oxidized to NAD+. This is the oxidized. Okay, so now it goes into the shuttle, and this is where it crosses the membrane. It goes from mitochondria to cytosol. Okay, so now that it has been crossed, malate is then, via malate dehydrogenase, put back into oxaloacetate, but now it is in the cytosol of the cell. And this is, malate has been oxidized and NADH+ has been reduced. It is the opposite of what happened before. So now we have oxaloacetate on the outside of the membrane, which we wanted. So now we can use
outside. It's in the cytosol.
It's in the cytosol, but outside of the mitochondrial membrane. Sorry about that. Okay, so oxaloacetate is now can be converted to phosphoenolpyruvate via PEPCK, which is phosphoenolpyruvate carboxykinase. And what this does, it adds an ATP equivalent known as GTP, which adds a phosphate to it, and also loses the CO2 that was added earlier by the pyruvate carboxylase. This type of enzyme is a transferase. And then and then overall the reaction has a delta G of positive 0.8. It's an inorganic reaction because the CO2 is a gas and makes a great leaving group.